In this video, we are going to do a derivation of coefficient of volumic expansion. Okay, so for the purpose of this video, we assume that by now you know the formula for linear expansion, of which that's what we are going to use. We know that, let me say, you have this metal and it is taken to a thermal pressure. Maybe there is a change in temperature of something that I don't know. This thing is going to expand some change in length. Okay, that's why in bridges there are spaces, so they are trying to take into account the expansion caused by any thermal pressure, or maybe thermal change, I should call it like that. Okay, so we have a formula for this. We're saying that the change in volume, the change in length, linear expansion, is going to equal to some coefficient alpha. What else? I think you'll have your length initial, and you also have your change in time. Temperature, obviously. Okay, your change in temperature there. Okay, and this is your linear, this is your coefficient, right? This is coefficient expansion, linear one. Okay, that's what we're going to use to go about this derivation. So this is your setup. You start up here. What else? I think that's all. Then if you know this, you can now start. Okay, for the purpose of the video, again, we are going to be working on a cube. This is the cube that we are going to be working on. It has L. So the volume for this cube that I'm working with, it's going to be length times length times length. All these lengths are equal, length, breadth, and height, whatever, they're the same. So then we can have L3 is equal, L power 3 is equal to volume of our cube just here. Okay, so that's good. Let's take back our friend just here. Let's just work with him a little. We know that change in length is like length final minus length initial. Sometimes call it length naught change in temperature, time, as I did that at time. And then now we have our length final equals to, we take this to the other side, obviously it will be positive, to be length O alpha length there should be a plus, alpha length change in temperature again. Okay, then from here we notice that we have this and this here. We can obviously do what, factor it out, right? And then if I factor it out here, I'll have 1 plus, here I'll have alpha coefficient, linear coefficient expansion, and here I'll have my change in temperature again, like this, and this give me length. So now we have a formula for length. That's how you start up your derivation. Whoever is marking this to see every step of the way. So now we remember that volume of the cube is equals to V is equals to length power 3, right? So we know the volume is going to equal to, but we do know something else. We know this again for the length, so we just can say LO open 1 plus alpha change in temperature close, that all should be squared, because whatever is here denotes the length. We just set that here. Okay, now we have a good setup. So this L is going to get, L naught is going to get the 3 on top, and this 1 plus alpha change in temperature is going to get a 3 on top. Good. So this was just easy, but now how do we handle this? We are going to do some algebra background class, a very quick one, just here. I'll just erase it after. You don't need what I'm doing for the proof. I'm just trying to show you from now on. Okay, let me just change the pen. Whatever is in blue, you don't need it for your exam. It's just for me trying to make you understand. Okay, it is like this, right? How do you sort something like this? Because it's in the same nature as this one. This is my A, all this is my B. Okay, I'm trying to make you understand how I did this. I just plug it here as a formula, right? Okay, so this is same as A plus B all squared multiplied by A plus B, because you just add the exponent, get back here. Okay, but we know how to handle quadratic. That is the easiest to work with, right? Quadratic, you square the first one, you times this, and then you get, then you times by 2 is going to be 2ab, this and this times 2, then you take the last term, you square it. It's going to be like this, right? Remember, you still have a plus b, then you do the distribution, the FOIL. You give everything a, you give everything b. If I give everything a, it's going to be a cubed plus 2a squared b plus ab squared. So remember, everything in blue you don't need for your proof. I'm just trying to help you out how I get stuff. Okay, now I've gave everything a, let me just give everything b. It's going to be a squared b plus 2a 2ab squared plus b cubed. Okay, then the next thing you'll want to work with is obviously there's nothing with the third degree in a, the like terms, right? You'll want to work with the like terms. Okay, this one, it's 2a squared, and this one will give me plus 3a squared b, and this one is b squared. There's another one of that nature here, ab squared is going to give me a 3a b squared. I think I've circled everything except this should have been cubed, because it should have been this and this should have been cubed, and then it goes up like this. So there's nothing you can do here. This is the formula that I will be using. So you need this formula just to put it here. So whatever I've written here, you don't need all of this for the proof. But for some clarity, you can show this formula, or maybe just do it in a pencil, or what I did, or you can just have it in your head. Some people have it, I don't. Okay, then go back to the proof now. Okay, this is our a, this is our b. Okay, v is going to equal to L naught power 3 open a squared, this is a 1, a cube I mean, is going to be 1 plus 3, what is 8, 1 squared, doesn't change anything, b, you multiply by alpha change in t, good, plus another 3, what is a, it's 1, and then you square everything here, it's b, it's going to be this and this, good, and then is it square? Yes, it's square everything, then plus the last term is the b squared, it's going cube, I mean cube, alpha change in time, temperature, why I'm using time, physics. Okay, good. Then this thing is in the same nature as this formula, right? I just copied this thing just here. Okay, so just because of you write this, please, because of we are looking at very small change in temperatures, so we can just all of this neglect it, or I should say it goes to 0. Okay, some terms will go to 0, or just neglect them, whatever you wanna say it. Okay, all the terms that has t squared or cube whatsoever, or t to some big degree, will be will just disappear, will be neglected. Okay, we have L3, we know that should be V naught, by the way. This, just call it V naught, open, and everything else is neglected. And now I have 1 plus 3 alpha change in temperature. Good. And if you notice, it's going very well. So this is going to be my V, and then I distribute this, is going to be my V naught plus 3 alpha V naught change in temperature, obviously. Then I take this to the other side, I'll have V minus V naught. It's going to be 3 alpha V naught. I just factored out V naught, did I? Yes, I factored out V naught, so I don't have it now, so it's going to be like this. Yeah, I factored it out and then I move it to the other side. So now this is going to give me my change in V is equal to 3 alpha change in temperature. Let me just write it for me now. This is for me because I don't listen. Okay, temperature. Okay, that's good. So we can then change this into another constant or coefficient, of which is just what we trying to prove. So I can say here 3 alpha is can be thought of as beta, of which is volumic thermal expansion. So we have derived this formula using what the formula that we know, thermal expansion, linear one. So if you're looking for derivation of coefficient of volumic expansion, you have it here. So if there's some part of the video you didn't understand, just scroll back and look what happened, and don't hesitate just to ask in the comment section if there is something that you didn't really understand. So can you please don't forget to subscribe, maybe even like and share the video with your classmates.